Hello everyone, myself Mayank Jhunjhunwala from IIT Kanpur. So today I am going to discuss trigonometric functions with you all. So basically trigonometric functions is a very important part of your JEE-Main. So you have to do it. So let's start with the very first slide. So let's start with trigonometric functions. See, basically there are six type of trigonometric functions: sine, cos, tan, secant, cosecant, cotangent. So let me define it one by one. Firstly, what you will do, you will take a triangle, and you will. Everybody knows that one angle is 90 degrees. Let me show it with a pen. 1 second. Mm, okay. So see, this angle is 90 degrees, everybody know. So this angle is 90 degrees. I'm not talking about this angle. Uh, Take any other angle other than 90 degrees. Let be this angle or this angle. So what is basically sine? Sine is the ratio of the side which is opposite to your angle divided by hypotenuse. What is hypotenuse? Hypotenuse is nothing but the side opposite to 90-degree angle. So this is hypotenuse. So what is sine? Sine is nothing but the angle which you have taken, that's opposite side divided by hypotenuse. So sine is opposite upon hypotenuse, which is CB upon CA in this case. Okay. And moving on to cos, what is cos? Sine is this upon this, and cosine is adjacent one. Which is adjacent one for A? This side is adjacent. So adjacent upon hypotenuse is nothing but cos function. So learn it this way: whichever angle you will take, the side opposite to that angle will come in sine, and the side which is adjacent to that angle will come in cos. So CB upon CA is sine A, and BA upon CA is cos A. I hope you get that. So moving on to tan A. What is tan A? Tan is nothing just ratio of sine upon cos. Or you can say it is nothing but opposite upon adjacent. Matlab, we have taken sine in opposite and we have taken hypotenuse. Basically in tan we will not take hypotenuse. So in tan is nothing but opposite upon adjacent. Opposite upon adjacent. So tan is equal to CB upon AB, which is written here. So I hope you get that. Uh, Now moving on to secant, cosecant and cotangent functions. What is sec? Sec is inverse of cos. इसका inverse होता है sec, and cosec is inverse of sine, and cotangent is inverse of tan function. So basically you have to learn these functions because these are actually important. So what is secant? Secant is 1 upon cos. So since it is 1 upon cos, so you can say it is adjacent upon hypotenuse. No, it is hypotenuse upon adjacent. Why? Because it is inverse of cos. What were we taking in cos? We were taking adjacent upon hypotenuse. So what we will take in sec, we will take hypotenuse upon adjacent. This is your sec function. Now what is cosec? Cosec is nothing but 1 upon sine. So in sine, what we were taking opposite upon hypotenuse. So in this, what we will take? We will take hypotenuse upon opposite. Simple. Okay. So I hope you get that. In cosec, it is 1 upon sine, sec is 1 upon cos, and for cot, it is 1 upon tan. So for cot, it is 1 upon 10. So you can say that it is adjacent upon perpendicular. And one more thing, साइन को अपन लोग perpendicular upon hypotenuse से भी define करते हैं, and for cos we take base upon hypotenuse. So these are the main names. The angle, the side opposite to your angle is perpendicular, the side adjacent to your angle is base, and the side opposite to 90-degree angle is called hypotenuse. So these are the major 6 trigonometric functions which you must learn by heart. You must remember these functions because these are very important. So moving ahead, these are some identities which we study in trigonometric functions. Firstly, let's take even and odd functions one. So in even and odd functions, what happens? This is something like this. Let's say this is your x and y axis. So sine graph is something like this, and on the opposite side it is like this. So basically, sine is odd function. What is odd? Odd means just sine of minus x is equal to minus of sine x. See, if you take pi by 2, you will get value 1. Sorry, 1 second. Okay. So when you will take value pi by 2, you will get 1. This is equal to 1. And when you will take minus pi by 2, you are getting minus 1. So it's basically just negative of what you are getting on positive side. So sine is a odd function, and you know for odd function what is the property? f of x f of x is equal to minus of f of minus x. Okay, so I hope you got it. Sine is an inverse function, the sine is an odd function. So sine of minus x is equal to minus sine x. Cos is an odd function because cos to graph is something like this. One second. Cos graph is something like this. So I hope you got it that it is an even function. Why? Because see, for negative value of a positive value of x, you are getting same value of y. So you can say that cos is a even function. So cos of minus x is equal to cos x. Sine of minus x is equal to minus sine x. Tan of minus x is again minus tan x because tan is also an odd function. Cot is also odd, so minus cot x. Cosec and sec are again cosec is odd and sec is even. So I hope you got it. You have to learn which functions are odd and which functions are even. Basically, sine function, tan function, cot function, cosec function. These four functions are odd functions, and only cos or its opposite, which is sec, is even function. So please, we learn these identities. So moving on to periodic functions. What is periodic? So again, let me make graph of sin x to make you understand. Uh, it is something like this. Okay. So basically, this is your 1 and this is your pi by 2. So what we have to check? We have to check at after what time period again 1 will come as your value, as your answer. So this is basically periodicity. So you are seeing that this is also 1. So from after how many after how many intervals are we getting 1? We are getting it after 2 and pi. Basically, see, this is pi by 2, this is pi, and this is again pi by 2. So pi by 2 plus pi by 2 is 2 pi. So basically, at intervals of 2 pi, your sine function is repeating. So that's why sine of x plus 2 n pi is equal to sine x, where n can be your any value, be it negative, be it positive, but it is an integer. So at every 2 pi interval, sine will repeat its value. So I hope you got that. Similar with cos, but for tan it is only n pi. That is after every pi, tan will repeat its value. N can be anything, but just take it to be an integer, and rest it can be anything. Here n belongs to integer. Okay, so please learn it. Sine is repeat after sine's value repeat after every 2 pi, cos value repeat after every 2 pi, tan value repeat after pi, cot value after pi, cosec again 2 pi, and sec after every 2 pi. So you can also do one thing, learn only for main functions, sine, cos, and tan, and inverse, and their inverse, which are sec, cosec, and cot, and sec, cosec, and cot. Always follow their main functions. So basically, sine 2 pi, cosec 2 pi, cos 2 pi, sec 2 pi, tan pi, cot pi. Same goes with even an odd function also. Sine is odd, cosec is odd, cos is even, sec is even, tan is odd, cot is odd. So learn only main functions, then you can easily do inverse functions also. So this is the thing about periodicity. Periodicity is nothing but what we have to find. We have to find the period after which the function will repeat its value. So for sine it is 2 pi, and for cos it is 2 pi, tan pi, cot pi, cosec 2 pi, and sec 2 pi. Or n belongs to integer. It can be any integer, be it positive, be it negative. So I hope you got that. Let's move ahead. Moving on to Pythagorean identities. So what are Pythagorean identities? These are nothing but some Pythagorean identities are square functions, which we adding two functions square, we will get one. So basically, there are three types of Pythagorean identities: sine square x plus cos square x. This thing is equal to 1. This is very important. Let me make it star. This is very important. In approx each and every question, you will use this identity. Not only in trigonometry, even in every chapter of mathematics, this identity comes again and again. So please learn it. Sine square x plus cos square x is equal to 1. Similarly, 1 plus tan square x is equal to sec square x, and cosec square x is equal to 1 plus cot square x. So these are also three types of identities which you should learn clearly. So moving ahead, now coming on to sign and difference identities. Sign and difference identity is nothing but this, let's say sine of x plus y is equal to sin x cos y plus cos x sin y. So let me explain you with an example. Let's take 30 and 30 angle. Okay. So sine of 30 plus 30 is sin 60, and sin 60 is nothing but root 3 by 2. Sin 60 is root 3 by 2. Okay. So we have to check LHS also. So for LHS, we have taken x and y equal to 30 30. So sin 30 is half, sin 30 is half, cos 30 is root 3 by 2. Then cos 30 again, it is again root 3 by 2. And sin 30 is half. So multiplied with half. So now you can see your answer is root 3 by 2. So see, LHS and RHS are equal. So you can prove it this way. Basically, these are sum and difference identities. When we will use this type of identities, when we want to convert sum to product form and product to sum form, we use these type of identities. So I know there are many formulas, but trigonometry is nothing but formula only. So you have to learn all these. Sine of x plus y is equal to sin x cos y plus cos x sin y. Sine of x minus y is equal to sin x cos y minus cos x sin y. You can do one thing. You can learn sine one, sine what happens in sine. In each product, both functions will come, sine and cos. See, cos and sine and cos, sine and cos and cos and sine. Just with negative, we'll get negative. Otherwise, we'll get positive. For cos, double function will come like cos cos sine sine cos cos sine sine. In plus, you will just reverse the sign in cos case. So here it is minus. Please remember it. It is very special case for cos. In cos of x plus y, for plus you will take minus, and for minus you will take plus. And here we will take double angles like both cos or both sine, but for sine we will take one sine and one cos. Okay. So coming on to tan, you can do this by taking ratio of sine and cos also. This I have not written there, so let me write it here. Tan is equal to sine upon cos. Okay. So tan is equal to sine upon cos. Can I lower it? One second. I don't think I can. Okay. So let's use this one. Okay. So let's use pen. So basically you can take tan as sine upon cos. So you can do it this way also. But let me prove it. Tan of x plus y is equal to nothing but tan x plus tan y upon 1 minus tan x tan y. So you can all again prove it this way. So let's prove it for your easy understanding. Let me prove it. See, tan of x plus y, let's take again 30 and 30 degree. So tan of 30 plus 30 is tan 60, and tan 60 is tan 60 is root 3. So here you have root 3. Root 3 is equal to tan of a plus b upon 1 minus tan of tan b. So since both are 30 30, so tan is tan 30 is 1 by root 3. So 1 by root 3 plus 1 by root 3. If you forget some identity, you can check it this way by putting simple values. So 1 minus 1 by root 3, again 1 by root 3. Okay. So this is the way. And from here you can see that what you are getting 2 upon root 3, 2 upon root 3 divided by 1 minus 1 by 3, which is 2 by 3. So 2 and 2 will cancel, and you will get 1 by root 3, which you will get 3, which is your LHS is equal to RHS, hence proof. So please learn this one also. And what is the difference between tan x plus y and tan x minus y? Here plus and sign interchanges, and on the denominator also plus and minus sign interchanges, and everything else is same. So if you will learn 1 1 1 identity also, you can easily reproduce second one. So I hope you got the feel of these ones. So let's move ahead. This is the table for some basic angles: 0 degree, 30 degree, 45, and 60, and 90 also. So at least you should have learned these type of angles. I know you. वैसे तो you should also learn 15 degree also, but you can easily calculate 15 degree if you know 45 and 30. You can just use sine of a minus b and do sine 45 minus 30, and you can easily calculate 15 degree. So this is the very basic table. If you don't remember this one, then then it is very hard for you to solve any trigonometric question. So please remember this table: sine of 0 is 0, sine of 30 is half, sine of 45 is 1 by root 2, sine 60 is root 3 by 2, sine 90 is 1. Similarly for cos, sine and cos are just opposite. For sine you go this way, and for cos you come this way. Both are same. So basically see, sine 0 is 0, cos 90 is 0, sine 30 is half, cos 60 is half, sine 45 1 by root 3, cos 45 1 by root 2, sine 60 root 3 by 2, cos 30 root 3 by 2, sine 91, cos 0 1. So basically if you learn sine, you can just reverse it for cos. And tan 0 is 0, tan 30 is 1 by root 3, tan 45 1, tan 60 root 3, tan 90 not defined. Tan 90 is not defined because it goes to infinity, and infinity is not defined. And again, if you learn tan, cot can be just reversed. See, again, you go this side for tan, and you come this side for cot. So basically, tan 0 is 0, so cot 90 is 0. Tan 30 is 1 by root 3, cot 60 is 1 by root 3. Tan 45 1, cot 45 1. So just you have to go this and that way, nothing else. So once again, cot is again we have defined, and sec is 1, and again for sec and cosec you have to do nothing. You have to just reverse sine and cos. So sine 0 is 0, so cot 0 is cos sec 0 is undefined. Why? Because 1 upon 0 is infinity, which is not defined. Similarly, cos a is 1, so sec 0 is also 1, because 1 upon 1 is 1. For cos 30 you have 1 root 3 by 2. For sec 30 you have 2 by root 3. For cos 45 you have 1 by root 2. For sec 45 you have 2. For cos 60 you have 1 by 2. So reversing it we will get 2. 0, reversing it we will get not defined value. Similarly for sine, 1 upon 0 not defined. Here it will be 2. Here it will be root 2. Here it will be 2 by root 3, and here it will be 1. We are just reversing the value and nothing else. Okay, moving ahead. Trigonometric ratio of complementary angles. This is also very important because this is also something which you are gonna use in each and every chapter, which will be coming your way after these ones. So basically, one formula, this one, sine square theta 1, sine square theta, sine square theta plus cos square theta equals 1. This formula and these identities are very important because this will come in your use in each and every chapter. So please remember this one. So what is complementary angle? We know for theta, complementary is nothing but what is complementary angles. If sum of two angles is 90 degree, then we say that those two angles are complementary angles. What are supplementary angles? If sum of two angles is 180 degree, then those are supplementary. If sum of two angles are 90 degree, then those are complementary. So here, for what is the complementary angle of theta? It is 90 minus theta. So it is complementary angle properties. Basically, you have to remember them. Sine of 90 minus 30 is cos theta. Basically, you have to, how you remember this? You remember this way. 1 second. Firstly, make x and y axis. Here, all the angles are positive. Here only, you can remember it this way. ASTC. What is this? Here all angles are positive. A means all angles. S means sine. So here only sine is positive, and here only tan is positive, and here only cos is positive. Matlab, here inverse is also positive, like here sin and cosec are positive, here tan and cot are positive, here cos and sec are positive. So you can learn this way: add sugar to coffee. This is only a mnemonic if you want to learn. Add sugar to coffee. So here all angles are positive. Here sin and cosec are positive. Here tan and cot are positive, and here cos and sec are positive. So sin 90 minus theta, and remember this thing: whenever you get 90, angle will be reversed. Sine will change to cos and cos will change to sine. Cosec will change to sec and sec will change to cosec. Tan will change to cot and cot will change to tan whenever you get 90. If here it would be 180, then angle will not be, then sine will remain sine, cos will remain so cos, and everything will remain same. If you are getting 90, then it will change. And sine to cos, cos to sine, cosec to sec to cosec, tan to cot, and cot to tan. Okay, so since you are doing 90 minus theta, 90 minus theta is here, and here all angles are positive, so you are getting cos theta. But positive and negative, you are, how you will say it? You will say it from this angle. If sine is positive, then here it will be positive sign. In 90 minus theta means this quadrant, sine is positive, so you are getting positive. Again, cos of 90 minus theta, again this quadrant, so positive. So here all angles are in first quadrant, so all are positive. So here also all are positive, and sine changes to cos, cos to sine, and this way. So just remember this quadrant rule: add sugar to coffee. Or here all are positive, here sine and cosine are positive, here sine and cosec, here tan and cot, and here cos and sec. Okay, so I hope you are getting the feel of this. Moving ahead. So coming on to general solutions, what are general solutions? If you are given sin x equal to 0, then how can you interpret this equation? Matlab, how can you calculate the values of x? So basically, these are some basic equations. If you are solving a question and your final answer is coming something like this, and you want to tell to the instructor what is the final angle. So basically, in this type of case, sin x is equal to 0, x is equal to n pi. That is for all values of n integers, obviously. Here n belongs to integer. So basically for all values of n, 0, 1, 2, 3, sin pi is 0. So sin x equal to 0, you can represent it through x is equal to n pi. Similarly for cos x equal to 0, again for x equal to n pi plus 2, you can again, here n is integer for everyone. N belongs to integer. So put any value, let's say put 1 or 2, anything you can. So putting 1, pi plus pi by 2 is 3 pi by 2, and cos 3 pi by 2 is 0. That is cos is always 0 for every n pi plus pi by 2 angles. That is for every 3 pi by 2, 5 pi by 2, for every this type of angles, cos is 0. So these are general solutions which you must remember. Similarly, tan x is equal to 0 for x equal to n pi, cos x is equal to 1 for x equal to 2 n pi. Similarly, sin x equal to sin x equal to sin theta, cos x equal to cos theta, and tan x equal to tan theta. So these are half angle formulas which you must remember, and I hope you are doing so. So this is half angle formula: x equal for sin x equal to sin theta, x is equal to n pi plus minus 1 ki power n into theta, where theta is basically when you will use it, you will use it only when you are given two angles, x and theta, and you want to compare them. So this is the basic comparison. Similarly for cos and similarly for tan. And one thing more, here theta is varied from minus pi by 2 pi by 2 only, and for similarly for cos and tan, you can check it from 0 to pi, and you can check it from minus pi by 2 to pi by 2. So this is general solutions, and we will do a question on this also in today's session, so please remember this one. And now coming on to two more basic formulas: sine and cosine rule. So what is sine and cosine rule? Sine and cosine rule is nothing, just take a triangle. Okay, so take this angle as C. Here you take A, and here take B. Okay, so basically this angle is opposite to C, so it is C. Let it, this is B and this is C. Well, take it like this only. This is A, this is angle C, this is angle B. So basically A upon sine A. Basically this is angle A, and the side opposite to this is also A. So A. Side opposite to this is also C, and side opposite to this is also B. So basically length of this side is A, length of this side is C, and length of this side is B. And how I assign these coordinates? I just took the side opposite to it. And C opposite to this side is this one, so this is C. Opposite to angle A is this side, so this is A. Opposite to angle B is this side, so this is B. So what you will do from after making this triangle, A upon sine A upon sine A is equal to B upon sine B is equal to B upon sine B is equal to C upon sine C. So this is basically your sine rule. I hope you remember it. This is very again important thing. You can take it equal to anything that's some constant k. Okay, so this is your sine rule. And then same with cosine. A square is equal to b square plus c square minus 2bc cos a. You can remember this also. This is very basic. Cos of a is equal to b square plus c square minus a square plus c square minus a square upon 2bc. And similarly, you can write the other two also for cos b and cos c. What you have to do, you have to just replace for cos b, here you will take b and here it will be AC and AC. For cos c, here you will take c and here it will be AB and AB. So just for remember one formula, you can write others very easily. Okay, so I hope you got all this theory part, and basically trigonometry is nothing but about learning formulas. So at the end, after understanding you have to learn formulas, this is the only way. So I hope you got that. So now let's move on to some questions. This is the very first question. So let's do this one. Here what is given, sec 4 theta minus sec 2 theta is equal to 2, and you have to calculate the general value of theta. Okay, so you have to calculate the general value of theta. How can you do that? Firstly, take this equation, sec 4 theta minus sec 2 theta equal to 2. Okay, so this is your general equation. Now what you will do, what I'm doing, I'm taking the inverse of it, so I can change it to cos. So basically, for changing it to cos, take its inverse. So you will get 1 upon cos 4 theta minus 1 upon cos 2 theta. 1 upon cos 4 theta minus 1 upon cos 2 theta is equal to 2. Okay, so I've just written second form of cos. So now take the LCM, cos 2 theta minus cos 4 theta upon cos 2 theta cos 4 theta. So that will go that side. So you will get 2. Because why I change it? Because working sine, cos, and tan is easy. Because we remember those formulas, and sec, cos, sec, and tan and cot is very difficult. So this is a general advice. Whenever you get a question in sec, cot, and tan and cosec, firstly change it to cosec. Firstly change it to sine, cos, and tan, so that you can easily solve it. So this where this equation came. We have just reversed the sec because we know sec is equal to 1 upon cos. So we use this one. From here, we get that minus cos 4 theta is equal to cos 6 theta. So minus cos 4, how we get that? You take cos 2 theta that side and take cos 2 theta common. You will get cos 6 theta. So from here, you can take minus cos 4 theta equal to, take cos 2 theta common. You will get minus 2 cos 4 theta, cos 4 minus not plus, sorry, 2 cos 4 theta minus 1. Okay. Then from here, you can use the identity cos 2 theta So basically this is identity na, cos square theta is equal to cos 2 theta is equal to 2 cos square theta, that one. So you can use here that identity and you will get cos 6 theta. So basically minus cos square theta is equal to cos 6 theta. So again cos 6 theta plus cos 4 theta equal to 0. So here use cos c plus cos d. So you will get 2 cos c plus d by 2, which is cos theta 6 theta plus 4 theta upon 2, which is 3 theta. 5 theta, sorry, my mistake. 10 upon 2 is 5. 2 cos 5 theta. 2 cos c plus d by 2, cos c minus d by 2. C minus d is 6 minus 4, 2, and 2 upon 2 is 1. So basically 2 cos 5 theta, cos theta is equal to 0. So from here, you get two equations. One is cos 5 theta equal to 0, one is cos theta equal to 0. So take both, because both are the same only, because whenever cos 5 theta is equal to 0, then cos theta is automatically 0. So when cos 5 theta is equal to 0, but you have to solve for both. So whenever cos 5 theta is equal to 0, so moving before, here what we have taken, whenever cos theta is equal to 0, x is equal to n pi plus pi by 2. So just do it here also. So here, firstly I'm taking cos 5 theta equal to 0. So 5 theta is equal to n pi plus pi by 2. 5 theta is equal to n pi, I'm using general solution, n pi plus pi by 2. And from here you can take 5 that side, and you will get theta equal to n pi by 5 plus pi by 10. That's only written here. So n pi by 5 plus pi by 10. Similarly for cos theta equal to 0, theta equal to n pi plus pi by 2. Theta equal to n pi plus pi by 2. So this is also your solution. Theta equal to n pi plus pi by 2. Okay. So basically here it is nothing, they have taken LCM. So you also take LCM, you will get 2n plus 1 pi by 2. So this is only that thing written, and these two angles are your answer for theta. So I hope you got that. It was not tough. You have to just use some trigonometric identities, and you can get it here easily. What you will do here, you will take cos 2 theta common, because cos 2 theta is here also and here also. So taking cos 2 theta common, you will get 2 cos 4 theta minus 1. Then you can use here that identity, cos 2 theta is equal to 2 cos square theta minus 1. And from here, substituting, you will get cos 6 theta, and then you can move ahead. So this was an important question which illustrates the example of using trigonometric identities. So I hope you got it. Let's move ahead. Now moving on to this question. Sec square tan inverse 2 plus cos x square cot inverse 3 is equal to what? So for easy convenience, I'm taking tan inverse 2 equal to alpha. So I'm taking tan inverse 2 equal to alpha. Okay. So from here, taking tan that side, you will get 2 equal to tan alpha. I hope you have worked with inverse trigonometric functions before. So here you are getting tan alpha equal to 2. And similarly, you can take cot inverse 3 equal to beta. Cot inverse 3 equal to beta. So basically what you are just doing, you are taking cot that side. So you are getting 3 equal to cot beta. 3 equal to cot beta. Okay. So you have got these two equations. Now just substitute here. So you will get sec square alpha plus cos x square beta. And you know, I have just shown you here. 1 second. Sec square alpha is equal to 1 plus tan square alpha. And similarly for cos x square, 1 plus cot square alpha. So that's what I'm using here. So using that, we will get sec square alpha we will write 1 plus tan square alpha, and for cos x square we will write 1 plus cot square beta. So we are getting this one. So this is equal to 2 plus tan square alpha plus cot square beta. Tan alpha is 2, so square would be 4. So this thing is equal to 2 plus tan square alpha, tan alpha is 2, so its square would be 4. So 2 plus 4 plus cot square beta. Cot beta is 3, so cot square beta would be 9. So 2 plus 4 plus 9 is equal to 15. This is your answer. I hope you got it. Let me understand. Let me make you understand once more. Explain it again. So basically, I have taken tan inverse 2 equal to alpha, and cot inverse 3 equal to beta for my simplification. From here, I got tan alpha equal to 2 and cot beta equal to 3. So I use it here. That's why I've taken it out. So basically, from here, I got it. Now I'm substituting tan inverse 2 with alpha and cot inverse 3 with beta. So I will get sec square alpha plus cos square beta. Now substituting the values of both, sec square is nothing but 1 plus tan square and cos square is nothing but 1 plus cot square. So using it, 2 plus tan square alpha plus cot square beta, tan alpha equal to 2 and cot beta equal to 3. Substituting, we will get 15 as our right answer. Okay. So I hope you are getting all these questions. These are very easy. You have to just substitute the values and you can easily do this type of questions. Okay. So moving ahead, this is tan cot x is equal to cot of tan x, and then sine 2x is what you have to calculate. Okay. So what you will do here? So firstly, I have shown you these formulas. Not these. This one. Okay, this is not there. So let me write it here for you. See, what you will do here, one thing remember, cot x is equal to tan of pi by 2 minus x. Okay. Basically, I have told you there also. So I've just written it once again. So tan of cot x equal to cot of tan x. So basically, I've replaced tan x with pi by 2. I've replaced tan x with okay. I have to replace tan x. No. Okay. So let me replace it with cot of pi by 2. Cot of if I will write it here for tan. So tan x is equal to cot of same thing pi by 2 minus x. Okay. So substitute the values. Substituting tan for cot, we will get substitute cot for tan. So we will get tan of cot x, tan of cot x equal to substituting cot with tan of, for replacing cot with tan, you have to use pi by 2 minus x. So tan of pi by 2 minus x. And what is x here? Here x is equal to tan x. So pi by 2 minus tan x. Okay. So from here you will get cot x is equal to again you have to use here general formula. So let me show it here. See, when tan x is equal to tan theta and x is equal to n pi plus theta. So here this thing will be used. So let me write it here. See, tan x equal to tan theta here also. So x is equal to what we will use. We will use x is equal to n pi plus theta. N pi plus theta. Okay. So here this thing is your x. This thing is your x. And this whole thing is your theta. So using it, so x is again cot x रखा, cot x is equal to n pi plus For theta, we will take pi by 2 minus tan x. So plus pi by 2 minus tan x. Okay. So take it that side. So you will get cot x plus tan x is equal to n pi plus pi by 2. Let me erase it. So you have taken out till here. Now again replacing cot with sine upon cos, because I have told you that whenever you will get sine, whenever you will get cot, cosec, cot or tan, change it to sine and cos, because working in sine and cos is very easy. So just change it here. So cot is cos upon sine. So cos upon sine, obviously x, plus tan x. So tan x is sine x upon cos x. So plus sine x upon cos x, sine x upon cos x is equal to n pi plus pi by 2, but I am seeing it here only. So basically what you will get डिनोमिनेटर में एलसीएम लेंगे तो sin x cos x, and here it would be cos square x plus sin square x, and there we will use identity. So you will get cos square x plus sin square x, which is nothing but 1 upon sin x cos x, which is equal to, this is the very important identity which I told you again and again, 1 upon sin x cos x, 1 upon sin x cos x. Okay, so that's why we write here 1 upon sin x cos x. This is equal to n pi plus pi by 2. Then sin x cos x is, you use this formula, sin 2x. Sin 2x is equal to 2 sin x cos x. Use this formula. So basically, for solving trigonometric question, you should learn formulas, because those are very important. Otherwise, you can't solve these questions. Okay, so it is 2 sin x cos x. So just use that. So here sin 2x, so I have to multiply by 2. So that's why I divided by 2 here also. So I get n pi by 2 plus pi by 4. From here, sin 2x is equal to 2 upon n pi plus pi by 2 basically. Just I have reversed it. So I got 2 upon n pi plus pi by 2. And from here, I get, 1 second. Yeah, I was asked sin 2x only. So sin 2x is equal to 2 upon n pi plus pi by 2. And taking LCM and all, we will get 4 upon 2n plus 1 pi. Okay, so here my answer would be 4 upon 2n plus 1 pi. 2n plus 1 pi. Okay, so I hope you got it. You have just used simple trigonometric formulas to get to our answer. Okay, so moving on to next one. The general solution of sin x minus 3 sin 2x plus sin 3x is equal to this is what? Okay, so again, doing the same way. Okay, so what can we do here is, minus 3 sin 2x is that it, as it is. So minus 3 sin 2x minus 3 sin 2x, and plus 3 cos 2x is also that as it is. So we will not touch these two. What we will do basically is, we have to play with cos x and cos 3x. Okay, so apply cos c plus cos d formula here. You will get 2 cos c plus d by 2 and 2 cos c minus d by 2, cos c minus d by 2. So basically it would be, 1 second. Okay, here sin are also left. No, okay. So basically what you are doing, you are taking cos x plus cos 3x. Okay, so use cos c plus cos d formula. You will get cos c plus d by 2, which is cos 2x. Sorry, which is cos 2x. This thing is equal to cos c plus cos d is equal to 2 cos c plus d by 2. C plus d is x plus 3x 4x upon 2 is 2x. So 2 cos 2x multiplied by cos c minus d by 2. So I've taken c this and d this. 3x minus 2x is 3x minus x is 2x upon 2 is x. So basically 2 cos 2x into x. Similarly, sin c plus sin d, sin c plus sin d, sin x plus sin 3x. Okay. So this thing is equal to, again, sin c plus sin d is 2 sin c plus d by 2. 2 sin c plus d, 4x upon 2, which is 2x. So 2 sin 2x into cos c minus d by 2. So basically cos c plus cos d is 2 cos c plus d by 2, cos c minus d by 2. But sin c plus sin d is 2 sin c plus d by 2 and cos c minus d by 2. Again, it is my take, so I am taking 3x as c and x as d. So 3x minus x is 2x, 2x upon 2 is x. So basically this thing is equal to 2 sin 2x into cos x. So here it is written. So I hope you get how we got this step. Now take sin 2x common from these two. You will get 2 cos x minus 3, which is written here, and take minus cos 2x common from here. So you will get 2 cos x plus 3. 2 cos x minus 3, sorry. So this thing is written here. Now making two formulas equal to 0. So one is sin x minus cos sin 2x minus cos 2x equal to 0, and one is 2 cos x minus 3 equal to 0. So solve for both. What we have done here, we have taken sin upon cos. Basically, I have taken sin 2x upon cos 2x. Sin 2x, I have taken cos that side. So it would be upon cos 2x equal to 1. Okay. So from here we get tan 2x equal to 1. And you can see here, when tan x is equal to, okay, it's just not written. No problem. So tan 2x equal to 1, tan x equal to 1 implies, let me write it here, tan x equal to 1 implies x is equal to n pi plus pi by 4. Please learn it, it is again important, n pi plus pi by 4. Okay, so here since x is equal to 2x, so we have taken 2x, so 2x is equal to n pi plus pi by 4, and x is equal to divide by 2, n pi by 2 plus pi by 8. Similarly, you can do it for here also. 2 cos x is equal to 3. I have taken 3 that side, and cos x is equal to 3 by 2. Okay, so from here you can see now that we are getting cos x equal to 3 by 2, which is 1.5. And we know that the value of trigonometric function sine and cos is between -1 and 1. You cannot go beyond 1 and you cannot go before 1. So basically, you are getting -1 to 1 as your range for sine and cos functions. That's why cos x is equal to 1.5x, 1.5, which is not possible. So only this thing sine x equal to sine 2x equal to cos 2x is your solution. So basically, x equal to n pi by 2 plus pi by 8 is your final solution, which you have to learn, which you have to derive basically by this way. Why we have neglected this, I hope you understand. We are getting cos x equal to 3 by 2, which is not possible. That's why only one solution, which we will get from here. Okay, so I hope you got it once again. Okay, so let's move ahead. One second. So let's move to this question. In this question, you are given, okay, we are now, let's do one question on sine rule. Sine rule. Okay, so let's do this question. What is given here? It is given if angle A is 45 degree, B is 75, then A plus C root is what? So basically, since two angles are given, let's calculate third angle firstly. And you know that sum of angles of triangle is 180. So for calculating angle C, you have to subtract it from 180. So basically 180 minus 45 plus 75. So you will get your angle C as 60 degree. So now since we have to calculate the answer in sides form, so we know that for going from angle to side, we use sine rule, which is A upon sine is equal to B upon sine is equal to C upon sine C. So I use this rule. A is 45, so A upon sine 45. B is 75, so B upon sine 75, and C is 60 degree, so C upon sine 60. Okay, so sine 45 is 1 by root 2. So you will get root 2A equal to b upon sine b. B is 75 and sine 75 is, remember, let me write it here. I know I told you that you should remember this formulas also, but you can easily calculate it using sine c plus sine d, sine of a plus b, sorry. So what you can use sine 30 plus 45, sine 30 plus 45. Or you can generally learn sine 75 also, because these ones are something which if you learn you can easily go through in JEE-Main, because JEE-Main is MCQ type of paper. So if you learn the values, you will be in profit. So basically, one thing once again. So root 2 is equal to, so using sine A plus B formula here, which is sine A cos B. So sine 30 is half sine A cos B, cos 45. Cos 45 is 1 by root 2 plus cos A sine B. Cos 30 is root 3 by 2 into sine 45, which is again 1 by root 2. Okay. So from here, what you are getting? From here, you are getting, since 2 root 2 is common in denominator, so add numerator. So the answer would be root 3 plus 1 divided by 2 root 2. Root 3 plus 1 divided by 2 root 2. Okay. So this is your final answer. I hope you got it. So sine 75 we used here, root 3 plus 1 upon 2 root 2, and sine 60 is root 3 by 2. So you can use it here. So you will get this equation. From here, do one thing, equate these two. So in equating these two, root 2 and root 2 will cancel, and you will get A equal to 2b upon root 3 plus 1, which is here. Okay. And now then let me erase it. Okay. So I hope you got how we get A. Now for computing C, equate these two. So when you will equate these two, 2 and 2 will cancel, and you will get C equal to root 2 into root 3 is root 6. So 3 will go in numerator. So root 3 into root 2 is root 6. So root 6 be upon root 3 plus 1. So this is my C. So I have got A, I have got C. I have to just do A plus C root 2. So do A plus C root 2. A plus C root 2. Put values of A and C. 2b upon root 3 plus 1 plus you have to multiply C by root 2. C is this thing, multiplying it by root 2. So you will get root 3b, because root 6 will cancel with root 2 and you will get root 3. Root 3b upon root 3 plus 1. Okay. So from here you are getting your answer as 1 second. I missed something, I think. A plus root 2c. Okay. You have multiplied it, no? So you will get root 12, not root c, sorry. So let me make it 12. You are not dividing, you are multiplying. I divided it somehow. So you will get root 12. So you will get root 12 here, since you are multiplying 6 by 2. Now take root 3, you will take 2b common. Take 2b common, and you will get 1 plus root 12 is nothing but 2 into 2 into 3. So basically take 2 outside, so you will get 2b outside, and root 3 will remain. So it would be 1 plus root 3 in bracket divide by 1 plus root 3. Okay. So on cancelling it, cancel this and this, you will get your answer as 2b, which we have to calculate. So our answer is nothing but 2b. Okay. So I hope you understood each and every question. I explained it as much as I can do. So basically nothing, there is nothing, you have to just learn formulas. If you are well versed with trigonometric formulas, then you can easily, it will be in your instinct that in which question you can easily use this formula. If using this formula will make my question easier, then I should use this one and this one. If you will remember formulas, then you can easily do these type of questions. But remembering formulas is necessary for this chapter. So please learn it. If you learn, then it will also be helpful for you in JEE-Mains. You don't have to derive it there. So please do this thing. Thus, this chapter is a bit difficult, but if you solve 2-3 questions, not 2-3, but if you solve 10-20 questions, then you will get a feel of it, and then you can easily go ahead with it. So I hope you understood it. Thank you.